Fine, sir.
Okay, that's good. So what we studied last time, do you remember?
I have to check. Sir, I had my science test today.
Oh, so how was the test?
Okay, sir.
Only okay?
Yes.
Why? You didn't answer all the questions.
Sir, I answered all the question, but
Hmm.
I forgot this thing, density thing.
You forget about the density.
Yes.
So it was from liquid chapter,
Yes, sir.
or
Oh,
what
sir,
was
this one.
in which topic it was asked?
Sir, this uh, liquid one, sir.
Oh, liquid one.
Sir,
Actually, you didn't answer because we didn't cover that liquid part, no?
sir, we did it in class, but we didn't do it in the tuition, sir.
We didn't solve study those things over here, right?
Yes, sir.
That was the problem. Oh, actually, you have only one class in a week. Okay,
Yes,
so
sir.
syllabus to complete syllabus, at least there should be two class, right? You don't
Yes, sir.
think so? That's why we are a bit slow. Today we will be going to study about the pressure and all, density and all, right?
Yes, sir.
That is, we have today's plan in that. Okay, so we have the densities in discussion today. Okay,
Yes, sir.
so just wait for 1 and 2 minutes. Okay, and we will
Okay.
start. Okay, you are alone today, right?
Yes, sir.
We didn't get any, so just wait for 1 or 2 minutes. Then we will start this chapter. Okay, so two guys. Hi Riyaz, how are you? Hi Riyaz, how are you?
Fine, sir.
Uh, so how's your exams going?
Yes, good.
It's already happened or it's exams over or scheduled?
This week's over.
It's over. So how was your test? How was your exam?
Good.
Do you have any difficulty in any questions? You may share with us.
No, sir.
Okay, good. So we already solved couple of questions last time. Okay, and the
Oh,
question was from your side only. So today we have to start pressure. Okay, pressure. So have you heard this word pressure anywhere in your daily life? Have you heard about pressure? Pressure. Yes or no? Actually, to understand pressure, just take your palm. Okay, this is the nib part. Just you push
yes,
it.
sir.
You will feel the pain. You will feel that something is being. Uh, who is this? I think this is the another one. So now we are complete class. Avani. So hi Avani, how was your test?
Sir, it was good.
So you answer all the questions?
Yes, sir.
Okay. So do you have any doubts from your question paper?
No, sir, I don't have.
Oh, that's good. So today we're gonna study about the pressure. Have you heard about the pressure earlier?
Pressure is the amount of force acting on an object.
Okay, amount of force, that is like force per unit contact area, force per unit contact area, per unit contact area. Contact area is equal to force. Pressure, Pressure. Pressure. So contact area is important. So I was giving an example. This is the pen tip and I am just putting it and pressing it. Okay, I'm pressing it. I'm feeling the pain. Okay, now what I'm doing, I'm just reversing it at the back side. And now I'm pushing. Okay, you too can do this and feel the differences. Okay, so when we press from this side, because this area is large, so it's tough to get into our palm. But if we will do from the tip side, it will go in bit easy way. So if area is less, pressure will be
Pressure
more.
is more.
Okay, if area is more, pressure is less. So we can write it. Pressure is Pressure is directly proportional to force. Okay, and pressure is we say it 1 over area. Clear? That's why if we wanna pierce something or make a hole in wall, what we use? We use needles. Okay, needle goes into the wall easier. Or for the injections, we always use a sharp needle, but we can't use the heavy large area part. It won't go inside our skin or the wall. That's why we use needles as a drilling machine, drilling objects. Clear? Now we have these two cubes. Okay, so we have to find the pressure and tell if this is A box and this is B box. So I'm asking you to calculate the pressure due to box A and pressure due to box B. Can you able to do it? Can you do it? Use this formula only. Pressure is force per unit area. So what is the part in question? 5 kg. Its weight is 5 kg. 5 kg. 5 kg. The mass is 5 kg, not weight. Mass is 5 kg. So Avani, can you calculate the pressure in both case? Jabbar, Imtiaz, sorry, Riaz, can you calculate the pressure in both case?
Sir, can you write the formula down?
Okay, pressure formula is this is only force per unit area. Force divided by area of contact. So in this problem, the contact area will be this. This part, right? And in this problem, the contact area will be this one. Just visualize, I tried. Once you are done, let me know.
The A is 0.025.
Area is 0.025. So A, you are saying about pressure.
Yeah.
Okay, so I have to check. Okay, okay. For the case over here, the force will be gravitational force, right? Gravitational gravitational force. What is gravitational force? That is mass into gravitation due to acceleration due to gravity. So weight is 5 or take it 10. Okay, so it will be 50 kilogram meter per second square. This means Newton, right? And area will be, what will be the area in this case? Tell me what will the area?
200.
200. So first we have to do 20 centimeter. This is 20 centimeters. So make it into meter. So it will be 20 into 10 to the power minus 2 meter, right? Because we have to do all the calculation in SI unit, remember? So make this habit. Whenever you are giving in centimeter or some other unit, make it into the proper unit, right? So this will be 20 into 10 to the minus 2 meter. And this will be, this side will be 10 into 10 to the power minus 2 meter. Clear? So this will be 20 into 10, 200 into 10 raised to the power minus 4 meter square, right? Meter into meter, that is meter square. Clear? Any doubt?
No, no, sir.
No, sir. So now substitute the value. So what I will say 50, I'm writing the unit as well. Newton divided by 200 into 10 to the power minus 2 meter square. So 1070 and 124. This is 1/4 or Newton meter square. So 1/4 is equal to how much? 1/4 is equal to how much? 0.25, right? 25. This was your answer? Newton meter square.
Yes, sir.
So this is 0.25. And Newton meter square is called Pascal. This is unit of pressure. Okay. SI unit of pressure is Pascal. Clear? What about B? Anyone solve the part B for
Minute.
block B? What?
Oh, sir, doing 1 minute.
Okay, do it.
Sir, for gravitational force, you have to multiply it by 10.
Yeah, that's the gravitational constant now. What is force? Force is mass time acceleration. In this case, acceleration is being provided by gravity. That's why I multiplied it by G. Or we know that value of G is 9.8. So I took, just for simplicity, 10, right? Clear?
Sir, clear.
Okay. Calculate for B.
Sir, 0.625 Pascal.
0.625. Okay, 0.625. Anyone else? Anyone else? Anyone else? No, no. Everyone is sleeping. Jabbar, are you sleeping? Yes, Jabbar is went. Okay. He's went. What about Riaz? He's sleeping. So Avani, force will be the same because mass is again the 5 kg.
10.
5 into 10, 50 Newton. We only have to find the area. Okay. So what will be area? I'm just writing directly.
800.
800 into 10 raised to power minus 4 meter square, right?
Yes.
So pressure will be 5 into 10 divided by 800. So pressure, I'm just writing P. This is 5 into 10, 50. I'm not writing this time the dimension. Okay. 800 into 10 raised to the power minus 4. Oh, did you notice one thing? Did you notice one thing? This 10 to the power minus 4 should be somewhere upstairs. Okay. So this is like this. I'll coming to the point, right? So 10 to 10 or 5 by 18, that is 16. This is 10 raised to the power 4. Clear? So 16 5s are 80, right? So this is 1 over 16 into 10 raised to the power 4. You got the point? This was the mistake. I'm coming to the first question first. In your calculation, it was okay. This is 1 by 4 into 10 raised to the power 4. Then only it will be in Pascal. So this is 0.25 into 10 raised to the power 4. So this will be 25, this much Pascal. Okay. This much Pascal. Clear?
Yes, sir.
So it will be this much. Here we have to solve 1 by 16 how much, and we have to put the 40. Any doubt? 1 by 16 will be 1 by 16. We have to see 1 by 16. This is 1.00 100. 6 time में 96. Remainder is 4, right? So this is almost 0.06 into 10 raised to the power 4. So it will be 600 Pascal. Clear?
Yes, sir.
Now I'm giving you the question in reverse direction. The question is, Jabbar and Riaz is sleeping. Okay. So now I have a question. If pressure is 200 Pascal, right? And area is 100 meter square, then find the force. Then find force. Can you do it?
Sir, can you show like one time?
What? Formula?
Just solve the question.
Formula?
Yeah. No, can you solve the question one time, then give us next.
A screenshot.
Okay, sir, done.
Okay. So try this question. Pressure is 200 Pascal. Area is 100 meter square. Then you have to find the force. Did you get the answer?
Sorry, 1 minute solving.
Okay, okay. Jabbar and Riaz is sleeping. They left the class. They just come and go. Rumaza, how are you?
Fine, sir.
Okay, so are you getting today's class?
Yes, sir.
Okay, calculate this question. This is simple question, okay? That pressure is equal to force per unit area, right? So we have to calculate the force, then force will be equal to nothing. Pressure, force will be A into P will be force, right? So just put the value of area is 100 into pressure is 200. So it will be 2 into 10 raised to the power 4 Newton. So see, that's why you might have seen in hydraulic a small cross section of area generates huge amount of force, right? A small cross sections of area can generate huge amount of force. Clear? See, this is 10 raised to the power of 4. It's the huge force. That's why this fluid or what can pressure is hydraulics are very powerful machines. Clear? Now we are moving to the further. We all know when we dip, this is water bucket. Okay. So when we dip, take this is a, suppose this is a water bottle, okay? Empty water bottle. Suppose you have an empty water bottle and you are trying to submerge it into the bucket, right? Is empty water bottle, you have just removed the water and air and you have tied it very well. So now you are trying to drop this water bottle. How would you feel? Avani and Umeza, Jabbar, Riyaz, how would you feel?
Sure, it will float.
It will float, right? If you will try to push it, the water will try to push it back, right? This is the mechanism. So we see that every liquids exert a pressure on a objects on its surface. So how this happens? That's called buoyancy. So these are few questions. Will you answer me? Have you ever had swim in a pool and felt lighter? No, you didn't swim. This happens when you will swim in water, you will feel lighter. Okay. Have you ever drawn water from a well and filled that bucket of water? No. This is outdated examples. Have you ever wondered why a ship made up of iron and steel does not sink in sea, but while the same iron piece would sink? Have you ever wondered about that? If not, then we will be learning it in the coming sections. So this is called the buoyancy. This is all because of buoyancy. Buoyancy is a tendency of a body to float or rise when submerged in a liquid. Okay, this is the boat, and this is you find that some part of boat is lying beneath the air, sorry, water, and some is above the water. Okay, so this whole system exert a force. If it is mass is m, then acceleration due to gravity will this side, okay, and this water will pull it upward, and this is being called buoyancy, and we will see or denote it by b. Clear? So when this, like this surface, when this tiny block is just floating on the water, it means that the force due to gravitation mg and a force being applied by this water over it, that buoyancy b is equal. Okay, when it is equal, it will be floating on the surface. Means that Newton's third law. If you put something on the table and table holds that, that's okay. If the object is heavier, the table will get break, okay, and that block will go down. So it is the same. This surface is like the surface, water surface is like the surface of table. You are putting some object, it is holding it. So this buoyancy will hold it, right? Clear? Okay. So we see that boat sink on the surface, but iron nails sink down. Okay, so why it happened? This happens because of density. Because of density. So formally we will give definition of density, that is mass per unit volume. So for iron, or cork. We see that iron is more dense. Its molecules are very closely arranged, right? But in the case of cork, you will see that these are very light. Okay, so the mass per unit volume is heavier for the iron case, and mass per unit volume is lesser for the cork case. That's why whose density is more with respect to that liquid will sink. Clear? So density of iron piece or iron nail, I'll say iron nail, and density of water, density of iron nails and density of water, density of water, iron nail density. Density of iron nail is more than density of water, more than density of water. Okay, so iron nails density is more than density of water, that's why it sinks. But the density of cork is less than the density of water, density of water. That's why it floats, right? Clear? Jabbar, you got the answer?
No,
So,
sir.
huh?
Yes, sir.
You got the answer. So how we calculate the density? I'm going to write it. We already written over there. It is mass. It is not weight. Don't confuse with mg. It is the mass. Mass and weight is different. We already discussed those things. So we say density as rho. Density, this will be mass into volume. Volume is what? Volume of this. Suppose this is one piece of cube or ice cube, right? This is the ice cube. This is the ice cube. Its area is, sorry, its length is A. So can you find it volume? Volume is volume. Volume is defined as area of surface. This surface, calculate the area of this surface. What will be the area of this surface, guys? If this is A, this is A. So what will be the area of this? What is it? This a square or rectangle? How we calculate the area? Romaza, how we calculate the area?
Volume is equal to area.
Huh?
Volume is equal to area.
Area of a rectangle. A rectangle is nothing but length into breadth. Breadth. So its length and breadth both is A. So it will be A into A. Okay, into height. So what is it height? The height of this cube is again A. Right. So volume will be A into A into A. That is A cube. Clear? The volume will be A cube. So we will put it A cube. So in this way, we will be calculating the density. Now my question is, tell me the density of ice or density of water. I'm asking you density of ice, density of ice, ICE. ice, you fill this with density of water. Density of water. You have to use the sign greater than or less than. Density of ice and density of water. Fill this box with less than or greater than. Density of ice. Rumaza, what is density of ice and density of water? Do you know any relation? Density of ice is less than density of water. Okay. Question.
Density of water is greater than the density of ice.
No. Density of ice is less than. Density of water is greater than density of ice. Right, right. Why ice FLOTS floats at the water surface? Have you seen floating ice cubes on the water surface?
Sir, dry ice.
No, no, dry ice. No, I'm not asking about dry ice. I'm asking you just go into the freezer, just take a cube, one small cube of ice, okay? Take one glass of water and put it. You will find what? Ice will be floating at the surface of water. It won't go into the bottom, right? Everyone, Jabbar,
Yes, sir.
this happens, na? Ice cube floats on the water surface. Riaz, ice
Yes, sir.
cube, does ice cube floats? Does ice cube float at the water surface?
Yes, sir.
Abani,
Sir,
does ice cube floats on the water surface?
yes.
Rumeza,
The density of ice is more than the density of water.
no. If density of ice will be more than density of water, then it will sink, right? See, if
Okay.
density is more, na, it will sink. If density is less, it will float. Clear?
Sir.
That's why ice cubes or ice float on the water. Okay, it doesn't sink. Clear? Now, I'm asking you another question. Suppose this is glass. This is a glass tumbler. Okay. And we are filling it till it edge with ice. Clear? Now I'm keeping it in the sun. The same tumbler I'm keeping in the sun, right? It is in the sun. Now ice starts melting. So what will happen? Does water will come out or not? Will water come out or it will like that? Did you get the question? Suppose this is a glass, okay, and we fill it with water, ice, till it mouth. Now I'm keeping that glass into the sun. So I'm asking whether when it converts into the water, so water will come out of glass or it will remain inside the glass.
Can you repeat it?
Okay, suppose I don't have glass right now over here. There is one glass. Okay, this is glass. This is glass. Tumbler or glass. Okay. So this is filled with ice till it mouth.
Okay.
Now I'm leaving it to melt it down. So I have put it in sun. Now this ice is converted into the water. Okay. So I'm asking that the water will come out of glass or it will just remain intact.
It will just remain intact.
Okay. So you all agree with this answer? So I already said that density is mass per unit volume, right? Mass per unit volume. Clear? Keep in mind. I'm just doing what? I'm writing it another way. Volume is mass by density. Clear? Any doubt? Now, for ice, I'm just keeping this constant, right? I'm not adding or not taking it back. So volume, we say that volume is inversely proportional to density, right? Means if density is less, volume will be more. Clear? If density is more, volume will be less, right? This is the thing. So density of ice, I'm only writing D. Density of ice is less than density of, I'm just writing water, right? Density of ice is less than density of water. Clear? Yes or no?
Circle.
Now keep these two relations. I'm writing it separately. Actually, I plan some lecture. Okay, after this, I will start this. But when we are in discussion, because of that knowledge, I'm asking you question and again and again. So now I'm writing the volume. This V of I will be proportional to 1 over D of I, right? I'm writing side by side. Similarly, volume of water will be 1 over D of water. So we know that the density of ice is less than density of water is more than density of ice. So I'm supposing that density of water, I'm just supposing it is 1 and density of ice should be less than it. So I'm supposing it 1 by 2. Clear? Clear or not?
Yes, sir, clear.
I'm just supposing it is not like that. Maybe or may not. Density of water is 1 and density of ice is less than that. So I assume that half. So now I will put it over here. So I have to put it 1 by 2 and here I have to put 1 by 1, right? Clear? Now simplify it. So volume of ice will be twice and volume of ice will be remain same. Water will remain same. Density of water. So it means that the volume of both is going to change, right? When one melt from one state to another state, the volume will change. Clear? Clear or not?
Sir, clear.
Everyone? Everyone or no?
Yes, sir.
So what is your conclusion now? It will remain intact or what? The water contained by the glass or tumbler is its volume. Okay. The liquid contained by the glass, it is volume. We measure that in volume, 5 ml, 3 ml. These are the volumes units. Okay. So now you get your idea and tell me what did you understand by this example. This all the scenario is clear to you. Now come up with your answer. Your answer that it will remain intact is wrong. And I given you the reason why. Now you tell me what will be when ice will melt into the water, what will happen? Are you able to answer me right now, or you will take time?
Sir, it will take time.
Okay, so you will you write a short notes for it, on it? You just
Yes.
keep this discussion with yourself. Okay. Ah. So density is less, volume will be more. Density is more, volume will be less. Okay. Now we move further. And I think the further next topic. Why the objects float or sink? This is only because of density, right? And buoyancy, that's it. Now one more thing we are left with is Archimedes principle. Have you heard about it, Archimedes principle? If you not, then make a picture of an object. This object's weight something, say 1 kilogram, right? Weight is not in kilogram, but weight is in Newton. So say 1 Newton, right? Now dip it into the water. What we are saying? We are saying that it is less than 1 Newton. This is you are seeing now. This clear or not? So this is only because that's when we dip an object into the water, the water, or one more thing, you will see that level of water in this tumbler is on this level, right? When we dip this object of this height, you might see that the level of water is increased. This is the Archimedes principle. If you are dropping 1 kg of water and your tumbler, sorry, not 1 kg, your tumbler volume is 100 or 100 milliliter, right? Or 100 ml, yeah. And you are dropping 1 stone of few gram weights. So you will find that the water is being drained out of tumblers, right? So it is only because that the block you have put in that has displaced the water of its own volume. Suppose this was your a piece of a stone of particular, say, X volume, right? And this is your tumbler. It is filled over here, right? It has Y volume of water. So when you will dip it, the water will come out, right? This happens. So it is being says that this box has displaced the equal amount of volume of water. This is being called the Archimedes principle. I hope you understand. If you don't understand, you may write this statement, understand. Archimedes principle states that upward buoyant force that is exerted on a body immersed in the liquid, whether halfly and fully, is equal to weight of the fluid that body displaces. That is the thing. Weight that body displaces. This is the Archimedes principle. And this is one of the fundamental principle in fluid. Clear? Clear or not?
Sir.
To everyone? To everyone, this concept is clear?
Sir, clear.
Okay, so this is the Archimedes principle. You write it. Either you take the screenshot. Okay, now I will ask you one story. Have you read the story of Clever Crow and Pebbles? A thirsty crow, right? Like it is like that. Thirsty crow. Have you read this story?
Yes, sir.
What is the story?
A story is about a thirsty crow. He was very thirsty and he found a bowl of water, and because of that, he couldn't put his beak through the water to drink it. So he put some pebbles. The water rose up, and he could put his beak and drink the water.
So the crow was clever, right? He was knowing that there is some principle. Archimedes. Later, Archimedes find it that is this principle. Was putting the pebbles of particular volumes. So the water was getting displaced. So he put a particular amount of pebbles. So the particular volume of water raised. And now he was able to drink that. That was the story of that. That was the theme of that story, because the crow was doing the physics, right? Physics. So if you know physics, you won't be thirsty, right? It's clear to everyone?
Clear.
So I think we are done for today, and we will meet next week. I'm giving you some assignments as well. So I think this chapter is also finished, na? This chapter is also finished. So I will give you good exercises. Okay, any doubt? This chapter is complete. Any
Sir, no
doubt?
doubt.
Everyone is happy? Everyone is happy? Everyone is happy, right? So it's time to end the class for